All right. I want to believe that from the last 3 examples that we have solved, whenever you come across any question using the Pascal triangle, you should be able to find your way out. Okay, now in this video, we are going to be discussing the second aspect of binomial theorem, which is known as what? The binomial expansion formula. If you could remember earlier, I mentioned that when it comes to using the binomial expansion formula, we bring in what we call combination. And at some point, you might have come across combination and permutation. And if you've never been taught that, maybe I'll do a video on that, permutation and combination, so that you can actually understand the whole thing. Okay, now let us look at what we have here. Binomial expansion formula. Now, in a situation where you have this, let's say we have x plus y to the power of 4. Remember, in Pascal triangle, what we use were the coefficient, and we say the coefficient are what? 1, 4, 6, 4, and 1. Now, in the aspect of using the binomial expansion, quite alright, if I am to expand this function, it simply means that I am going to have this. Now, I have my x, right? So, I am still going to have x raised to the power of 4. Then, plus. So, in the next place now, instead of me bringing in just the 4 as the coefficient, are we there now? We are going to write it as 4 to select 1. You say 4 select 1, or you can say 4 combine 1. Then you will now have your x, the power of your x, as we said, we reduce by 1, and then y we come in. Then the next one is what? 4 to select 2, or 4 to combine 2. And then you are going to have this to the power of 2, and then this one also to the power of 2. And then if you are to move further again, you say 4 to select or to combine 3. Then you are going to have x here. Then you are going to have, you are going to have y to the power of what? 3. And then the last one is 4 to select what? 4. Or 4 to combine 4. Then the power of x here is 0 now. Then you are now going to have y to the power of what? Of 4. Now, what does this 4 select or 4 combine 1, 4 combine 2, 4 combine 3, 4 combine 4 means? Because if you notice what we have just done here, you discover that the power here is 4. So that's why we're able to bring in this combination. How many times? 1, 2, 3, 4 times. So it simply means that whatever is your degree, so that is how your combination will also work with. So now, let me use this opportunity to explain what this 4 select 1 means. Now, from the knowledge of of combination, we're told that when you have n select r, it simply means that you are going to have it as what? N factorial all over n minus r factorial r factorial. Are we there now? That's what it means. So in a situation now where I bring in 4 select 1 now, but before then, what does the n factorial means? The n factorial simply means what? You are going to have your n 2 times n minus 1, 2 times n minus 2, 2 times n minus 3, like that till you get to the last part. So if I am to bring in 4 select 1 now, you will say that this is the same thing as saying 4 factorial all over 4 minus 1 factorial, and then the last one is what? You have your 1 factorial. Now, this is still the same thing as saying equal to 4 factorial all over 4 minus 1 is what? 3. So you are going to have 3 factorial, and then you have 1 factorial. What does a number with a factorial means? It simply means that 4 factorial is the same thing as saying 4 times 3 times 2 times 1. That's what it means. If I say 10 factorial now, it simply means 10 times 9 times 8 times what? Times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is what it means for a number and the factorial symbol. So it simply means that now, if you look at this now, this is 4 factorial, and at the denominator I have 3 factorial and 1 factorial. 1 factorial is 1. That means 1 times 1 is what? Is 1. Are we there now? So that means it has no effect on what we want to do. So that means if we proceed with this now, we are going to have something like 4 times 3 factorial, because I have 3 factorial at the denominator. So I will now bring all over 3 factorial and then 1 factorial. Like as I said earlier, I say 1 factorial does not have any effect, so you can even take it off. So what happens? That means 3 factorial will cancel 3 factorial, and at the end we are left with 4, which is still the same thing as the coefficients we have here using Pascal triangle. Are we there now? So same thing, if you do 4 to combine 2, you still have 4 factorial all over 4 minus 2 factorial, then 2 factorial. So what does this mean? This is the same thing as saying 4 factorial all over 4 minus 2 is what? 2 factorial, 2 factorial. So if I am to expand this now, this is the same thing as saying 4 times what? 3 times 2 factorial all over 2 factorial times 2 factorial. So what does it mean? This 2 factorial will cancel this 2 factorial. So what am I left with? I'm left with 4 times 3. What is 4 times 3? 12. What is 2 factorial? 2 factorial means what? 2 times 1. And what is 2 times 1? That is 2. So by the time we divide 12 by 2, what do you have? You have 6. You discover that we still have this. So this is what we call what? The binomial expansion formula. And in our next video, I am going to be using this to solve some example. See you there.